Welcome to our exploration of basic physics. In this video, we delve into the fundamental problems that showcase some of the most important concepts in physics, from understanding how objects move to exploring the forces that govern our universe. Each problem will provide insight into the underlying principle of physics, whether you are new to the subject or looking to review key concepts. This video is designed to help you build a strong foundation of physics. So grab your book and pencil and let's embark on a journey through the wonders of physics. In this case, we're going to start with the introduction to physics. When we said physics is the study of matter, energy, and fundamental forces that govern the universe, from the motion of the celestial body to the behavior of subatomic particles. Physics provides the foundation of understanding a natural world around us. In this introduction, we are simply going to explore some basic problems and their solution covering the key concept of physics. Let's start with the first problem, which is under kinematics. Let's assume we are given this kind of problem which says a car travels at a constant speed of 20 meters per second for 30 seconds. In this case, we are given the velocity to be 20 meters per second and time, which is simply going to be 30 seconds. And we are asked to find how far does it travel. When you hear the word how far, this is simply referring to distance. For you to calculate distance or the dynamics, this is simply going to be the speed multiplied by time, s multiplied by t. Our speed is 20 in meter per second. We're going to multiply that by our time, which is 30 seconds. In this case, seconds will cancel out. If you multiply 20 by 30, this is simply going to be 600. Our unit is going to be in meter. What about the second one? The second problem we have is under Newton's law. Let's assume I give you this kind of problem which says a 10 kg box is pushed with a force of 50 newtons. What is the acceleration? This is our box, 10 kg, and it was pushed, applied force which is 50 newton. When we set force, this is simply going to be ma, and in this case we also find the acceleration. A is simply going to be F divided by m, which is the same thing as writing 50 Newton divided by 10 kg. If you divide 50 by 10, this is simply going to be 5. Unit of acceleration is simply going to be Fm per second square, 5 meters per second square. Let's move to the third problem. This third problem is under projectile. Let's assume we're given this kind of problem that says a ball is thrown horizontally. Remember, this is vertical and this is horizontal. In this case, the ball is being thrown horizontally off a cliff. This is a cliff. It's been off from here down here. With the velocity, it has the velocity of 50 meters per second, and we are asked how far does it travel horizontally after 2 seconds. This 2 seconds, which is simply the time. We can finally conclude as since there is no vertical acceleration, the horizontal distance is simply going to be our velocity multiplied by our time, which is the same thing as saying 15 meters per second multiplied by 2 seconds. Remember, seconds will cancel out, and we are simply going to be left with 30 meters because 50 multiplied by 2 is 30. And this is it for this problem. Let's try another one. But this problem, before I start, I need to understand that it's based on work and energy. We are given a problem to say a force of 20 Newton, which is this, is applied to lift a box of what? Of 50 kg. This is it. How much work done is lifting it 2 meters? This is the height from here to here. How much work done we are asked to find when you try to lift it 2 meters. How can we solve this problem? In this case, we're simply going to say our work is going to be what? Our force multiplied by our distance, which is simply going to be 20 Newton multiplied by 2 meter. And the unit of work is joules. This is simply going to be 40 joules. And this is it for this problem. Let's move on to another problem, which is based on Newton's gravitational law. Let's assume we are given this kind of problem that says we should calculate the force of gravity between two masses, which is m1 and m2. One with 5 kg, let's assume this is 5 kg, or let's assume this is 10 kg, and this is 5 kg, which is the small one. And they said they were being separated by the distance of 3 meters. Let's say the distance from here to here is simply going to be 3 meters. Let's go back. They said we should calculate the force of gravity. So in this case, this is simply going to be, our force of gravity is going to be G multiplied by M1 multiplied by M2 divided by R squared. In this case, our G is the gravitational constant, and we are going to substitute everything to see how we can solve this problem. In this case, we are going to get the F, which is going to be what? The gravitational constant is simply going to be 6.674 exponential negative 11. We are going to multiply that by our first mass, which is M1, 10 kg. Remember to put the unit. We are going to multiply that by 5 kg. Divide that by what? 3 meter per second. And you're going to get your final answer. Feel free to pause the video and try it yourself. What about the next one? This problem is based on simple harmonic motion, which says a pendulum has a period of 2 seconds. Let's say time period is what? 2 seconds in this problem. And we asked to find the frequency. If you check on my other videos, we talk about frequency in simple harmonic motion, we talk about time period, we talk about average velocity, and many more. When we set frequency, this is simply going to be 1 divided by a period. When we set period, this is simply going to be 2 pi omega, which is something as saying 2 pi, the square root of m divided by k, which is the something as omega. In this case, we are asked to find the frequency. This is simply going to be what? 1 divided by period. Frequency is 1 divided by 2 seconds. And remember, the unit of frequency is hertz. In this case, we are going to be left with 0.5 hertz. Let's try another problem. In this case, we're going to be focusing on pressure. Let's assume we're given this kind of problem which says a force of 100 Newton. Let's say we're given a force of 100 Newton is applied. This is the force. It's been applied over area of 5 square meters. What is the pressure exerted? In this case, since we asked to find the pressure is simply going to be force divided by area, which is going to be 100, right, in Newton divided by 5 meter square. Unit of pressure is Pascal. Our answer is going to be 20 Pascal. And this is it for this problem. Let's try another problem on the electric circuit. Let's assume you're given this kind of problem that says a circuit has a voltage. Let's say it has 12 volts and a resistance of ohms, right? Let's say resistance of ohms is going to be, let's say we're given to be 4 ohms. What is the current flow through it? In this case, if we ask to find current, this is simply going to be voltage divided by resistance, which is the same thing as saying 12 divided by 4. Here we have voltage and here we have ohms. In this case, current is measured in ampere. Our final answer is going to be 3 ampere, because 12 divided by 4 is simply going to be 3. 4 multiplied by 3 is simply going to be 12. So here is going to be 4 amperes. Let's try the last problem under wave speed. Let's assume we're given this kind of problem which says a wave with a frequency of 50 Hz. We're given frequency to be equal to 50 Hz and a wavelength of what? 2 meters. Travel through a medium. The waves travel with this frequency, which is what? 50. And the wavelength moving up and down is just 2 meters. Right? And we asked to find the speed. In this case, our wavelength speed is simply going to be what? Frequency multiplied by, we can set our wavelength speed is simply going to be our frequency multiplied by our wavelength. This is simply going to be our 50 multiplied by 2 in meters. This is simply going to be 100 meters per second, since we asked to find what? The wavelength velocity. So this is it for this problem. See you next time. If you like this video, please don't forget to share, like, and subscribe. See you next time.